because there will be some question maybe for your quiz. Everyone here is in my class, I think. If not, then you're lucky and you can just enjoy the lecture. So I want to provide everyone with some basics for SPSS because I think we're all, I mean, even if you're very good in statistics and you've done some stuff in the past with various teachers, this is a review session for you, and I think will be very valuable. And I can say maybe there's a few parts that are easy and but I'm sure with this hour-and-a-half lecture, you will learn something, right? So if you ever have any question throughout the talk, you can type it. Confirm your speaking language. I'm not speaking Chinese. I'm speaking English. And let me save it. Okay. First, let me do is share my screen. I actually didn't prepare a PPT. I only prepared some data files that I want to share and show you all. And first, I think it's good that I will go. Let me see if I can remove the. I know you all need the. Nano, I'm going to mute you.
Chinese.
And Steven, I'm going to mute you too.
Oh, sorry.
Okay. All right. So all of you, if you're in my class, you've learned about my codebook. You can see this screen, right? You can see my codebook. If you can just type in the Zoom chat that you see it, that would be very good. Thank you. Someone typed. Thank you, Heching. Always so fast. Well, I believe most of you have this already turned in for my class, or you will be turning it in very soon. So remember, your code book is it's your ticket. It's basically everything that's in your data, everything you've asked, right? Usually you do it in order from the questions of the survey. You know, in this one, we're doing gender. Here, we're matching their name, the year which they're born, the university that they graduated from, their telephone number, and WeChat. We have IRB approval to ask these questions. So you may say, oh, that's very sensitive. These 5 questions, actually, we've been using for matching the people, because if you look down below, you can see Codebook T1, Codebook T2, Codebook T3, all the way to Codebook 7, right? So this codebook is so helpful for us because we're dealing with so many data, so much data, so many different time points, and it's been so long over time that it is truly been very necessary for us, right? So here we're looking at time 7, but if I want to go back and look at time 1, at least I've gotten something down that I can see. We measured this at time 1, right? This is essential for you, right? Essential for what you've been working on. You have your question that you're asking, and then here, these questions correlate maybe to your questions in your actual SPSS file, right? So as I know how hard that was for you to do the codebook assignment, it is essential for others to be able to understand your questions, right? Because when you're dealing with something like this of time 1 to time 7 data, and you have all these questions that you're asking at time 1, and all these questions that you're asking at time 2, and all these questions at time 3, obviously you need some place to really store things, right? I wish it was more complete, but it's good enough for our general needs as a team. Okay, so from Codebook, you might also have your data file, and this, if you go into Indra Machine or you go into Qualtrics, you might download, and this data file again will be huge, and it will contain all your questions and all of the raw data. Now, if you notice what we've done here, the structure of the data is very important because, again, if we're dealing with nominal data, you know, gender, university, here these questions are asking about major, those are all nominal data points. Now, if we're dealing with other things that are related to interval data, things that we're going to measure in a sense to calculate, to understand the relationship between variables, interval data is crucial and it needs to be done in number form, right? So when you download your data, you might download the file in two ways. I always suggest that you start with the Excel and you download the number-based, right? 有数字的. And then I always suggest that you download the one that has the 名称 that will have all of the information. So here, if this question is really strongly disagree, right? At least you have all of those down here where it says all of those say strongly disagree. However, when we use SPSS, we cannot use these. We have to use numbers. We have to know what those numbers represent, higher meaning positive or lower meaning positive, and the opposite applying. I'm going to just do a quick check for do a screenshot for my attendance. Actually, maybe I can ask quickly, maybe Miss Amy to help take attendance for my 5150, and I believe also for Miss Eva's class. And let me go ahead and ask Mungja if you could help to try to take the attendance for 4230. And you can work with Huan Li to do that. So everyone, please change your name to at least your name. Like this person, E. I have no idea who that is. I have no idea who this Hui Chen is. If you're in my classes, please make sure that you change your name so that it's very clear for us to be able to at least mark you being here. Anyway, so back to what I was saying, these numbers all mean something, and that we will be calculating them and computing them and making sure that they are reasonable, right? If someone answers 11111, those people might be very comparable in their data, and we might need to consider to delete them, right? Again, we've talked about this in my class. So I always say to start with your data here in an Excel spreadsheet. And what I do is I actually take these codes like this from my code book because I've labeled them this way. Let's just go to Codebook here, right? And I would take all of these items all the way down. And that's why I wanted you to start with your codebook first. And then I would do a new sheet here and I will transcribe them this way, transpose them, and now they're here. And then because I always say to use English for your codebook, I would, and for your data, I would then paste them in here. And then now they represent all of my items, right? Because you can immediately take your data from Excel and you can put it into SPSS. What I mean by that is you can immediately there's a function here where you can go here to import data. Let's see, import data, and you can go to Excel. If you prefer to use a CSV file, you can import the data set, and then it will immediately take the data and plug it in. And usually it's pretty good in recognizing the string data, and string data means nominal, and variables that are not nominal, that are numeric, right? Interval variable. As long as you've gotten your type of your data right here, meaning string, that's just telling you how many numbers or how many letters you want to make available for your, let me see if I can get rid of that. I want to get rid of this. I want to get rid of that little, how do I get rid of that? Oh man, I can't get rid of this. Oh man, maybe I just put it there in the corner. Okay, so it doesn't bother me. So your SPSS data file will contain two screens. First, it's going to contain this variable view, and then it's going to contain this data view, right? And you can interchange between them. All you do is just click the button below. Aside from your SPSS file where you have your data, another window will pop up, which is where it's called your output. And sometimes when you're running a lot of things and you're getting things confused, you might be unable to find this. And all you can do is just close it and you don't have to save it. And that's okay because you can always sort of rerun what you've done by going here to the most recent things you've been working on. So this little function here is going to say, oh, you must have recently run descriptives. And then it will show you what you had previously run. And then again, if you click OK, the data output file is going to come up, right? This is one file and this is the other file. Okay, so it's quite easy to get sort of confused or get lost in them because it is, you're dealing with, a lot as you're working with your data. Okay. So your data file is going to be, it needs to be structured in a way that's good for you. I always suggest that you use the name of your variable to match some code that you use for your scale. For example, if I'm interested in academic efficacy, academic efficacy contains 8 questions. Well, I'm not going to make my variable name called academic efficacy 1, academic efficacy 2, 3, 4, 5, 6, 7, 8. I'm maybe just going to use a shorthand name like AE, AE1, AE2, AE3, AE4, AE5, AE6, AE7, because when you're starting to compute variables, you might be typing, you might have to find the variable, and it gets kind of tricky, or it's very easy to get lost, especially when you're dealing with this many rows. You could see here's row 1, and if we go down, continue to go down, continue to go down, continue to go down. In this data file, we're dealing with, look, I mean, more than 1,700. I don't think these are all variables. I think we can just say from here to here. Hello. I'm very sorry about that. I don't know what happened. Yes, thank you, Fiona. Yes, there seemed to have been an internet issue. So, okay, back to what I was doing. I had just sort of cleaned out some of the data to make this easier for tonight and looking at the data. So, one of the first questions that we have to deal with when we're dealing with our data is we need to make sure that our data structure is correct. Okay. I think today I'm just going to mess around with, let's just use experimental mindset. Okay. That seems like to be a fun one. It might be very meaningful. Here in this file, there's ×6. There's also going to be ×7. There's going to be ×8. So the first question that I want to do, I mean, you'll want to clean your data and get everything ready for all of your data, but I'm just going to look at my experimental mindset for the time being. So let's just say I just want to look at some basic characteristics of the data. So I'm going to type in experimental mindset here. I'm going to type it in again here. I'm going to type it in again here. Again, I have never looked at this variable, so I don't know what we will find in that regard, but it may be very interesting. I'm going to look at experimental mindset time 5. I'm going to look at experimental mindset time 6. I'm going to look at experimental mindset time 7. We may find something, and this is all very much random. I just picked one. So let's see. So again, we've been from my code book. From my code book, we've been measuring experimental mindset from time 2 to time 7. And again, these are young people like you from 2022 to now. Okay. So just curious about this idea of how likely are they to be more experimental in their mindset and how much might this change over time? Let's have a look at the questions just so there's more content for you to look at. And if we look here, it's here. I treat it as an opportunity to try new things. I treat it as an opportunity or chance to explore what works and what does not. So the question is, in the workplace recently, how do you enjoy trying new things, right? Or how do you see your job and your workplace, right? So it's 6 items. It's not containing multiple it's not going to contain multiple dimensions. It's just clear 6 items. And we're just going to do some basic things to sort of gauge our understanding of the data. One thing that we want to do is look at the minimum and max. We can also add in the range, and that's fine. But I'm really just mainly focused on, did we make a mistake with the coding? Did one item somehow have 99? Does some items have -5, right? All of those questions can be answered by looking at this min and max. I believe this is 1 to 6, so that's very important. The next one that I think is very useful for a quick look at the data is the skewness and kurtosis. And these tell us just basically the distribution of this item by looking at all the people. There's times when we can accept certain skewed data. The most of the time, the data does need to follow normal distribution. I'm going to go ahead and ask Huang Qian to mute. And thank you. I got that one done. Good. So here's what it shows us. I'm putting all the items in there and then boom. Okay. First thing is first, it's going to tell us the number of valid data that we have. So for time 2, we have 405 responses. We have 533 that are missing, and that's perfectly okay. What that means is that in the data, maybe there's extra lines that have not been accounted for. So what I'm mainly looking at, because I know my data, are these numbers here, which represent a very expected number that I would have for time 2. Going over to time 3, we have 377, much what I expected. Time 4, we have 332. Time 5, 338. Time 6, 319. And then time 7, 316. So exactly what I would expect. Meaning there's not many missing items. So that's one important thing is, are we missing questions? Did someone answer it or did someone skip it, right? Generally speaking, these people, 332, all took the whole survey. Of course, it's not the same as 4 or 5. There are more there, but we expected when we were collecting the data that we had that many people. So everything's in line with our expectation. The next thing that I always look at is the min and max, because sometimes your data might show you something that's a little strange. You might find a -99. You might find someone that put 1 and there's an 11. We found with the data set with a few students in here, that one file was containing 1 to 100 and the other contained 1 to 7? These are very important questions that you can figure out very quickly. So again, we can see that this scale is probably 1 to 5, and at time 2, all of those questions are satisfied. At time 3, we can see the questions are 1 to 5, and all those questions are satisfied. At time 4, you could see there's 1 to 5, and all those are satisfied. And I could just quickly gauge everything and see, hey, there's no major problem, which is a very good thing, because that saves us a lot of steps in our data cleaning process, right? The next thing we can look quickly at are our skewness and kurtosis. And I quickly had done this for us to gauge. In SPSS, skewness and kurtosis statistics should be less than or equal to 1 to be considered normal. For skewness that is greater than 1, it's rightly skewed. And if it's less than -1, it is leftly skewed. And here we can see that we're under 1, 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 okay? -1. We look really good in the skewness. Some of the items get close to 1, some of them are 0.65. Okay, it's showing nothing that remains absurd or very, we would call an outlier, okay? And then quickly looking at kurtosis, we can see the same thing. There seems to be no problem or no trend or any issue with kurtosis. Meaning, in a very quick and brief way, we could satisfy some of the normal distribution features of this variable across 6 time points. There will be times when your data is skewed. I am more loose and lenient with it because I think there are other tests that we'll do later to identify those problems with data, where if there's skewness or there's some error with the data or some outlier. And I tend to, because I'm a cultural researcher and I all of my data samples are always so hard to get, that I'm always more loose with this practice at first. And if I'm finding some problem with my results or some of the analyses, then I will go back and sort of re-look at this more in detail if I need to. Some people are very strict with this, right? And there are several videos that I will share and I have shared in my file that you can quickly look at to see if there is this issue that you need to address. And I can quickly show you the file 5015. I click this. And if we go up here to this file, you can see this data set here. In here is going to have very comprehensive SPSS videos for you. If you want to go into detail about this, you can go into the data cleaning, which is very helpful. You can go into this variable about creating an ID in SPSS, and I should have provided the variable about outliers, but I'm not seeing it. So I will share that video with you all later. Okay. So that's very helpful. So the next thing I will do, usually personally, is sort of go down through the items and quickly look at how they're scoring and sort of gauge the range by looking at percentages and see, okay, they're around 4, they're around 4. Most people tend to be scoring around 4, and that's around 80% of the data, right? You can quickly just eye things and get a good sense of what's happening. This is also going to be helpful if you have a question or an item that needs to be reverse coded. And this is a very important feature of doing these quick inspection of your data, right? And the reason why you would notice it quickly is you see all of them tend to be going 3, 4, 5. Now, a reverse scored item, you would see it would be reversed from the other items, meaning all of these go 3, 4, 5. In a reverse scored item, we would see it be 1, 2, 3, right? We would see that reverse happening because that item needs to be transformed over, right? I'm going to quickly look at one. Let me just show you the next step. So because I'm fairly confident with this scale, what I would do is go ahead and begin just doing some basic reliability test, right? It's experimental mindset. We're looking at it across 6 different times. I'm expecting that it's going to be pretty reliable and pretty stable. Reliable is 可靠性 will be very high. And I'm going to expect it to be pretty easy to calculate and to do my next step. So I go to my reliability, and it's just you go to analyze, you go down, it's right below this dimension here, which is called dimension reduction. This is factor analysis. That's another step of the process you might want to consider. However, for most of our projects, I don't think we need to, okay? So reliability is right there. You click on it. And then again, it's experimental mindset. We can only do one at a time, right? So I'm doing time 2, right? I'm going to make sure time 2 is okay. I'm going to select a few things that I always do as a way of making sure if there's one item that's a problem, I can remove it, or I can at least get a sense of what the reliability would be like if that one's gone, right? So I usually click these, nothing complicated, especially scale if item deleted. That means if I take one of those out, what will the item look like? So here, as I said, with this scale, I expected a very high reliability, and we have one, right? A 0.867. It's 6 items. And then here, I can go down and see the inter-item correlation, which is right here, this one. And I can also see this one here. It says, if I take out this item, what happens to the scale? If I take out item 1, it goes to 0.8847. If I take out item 6, it drops to 0.856. And remember, we're already dealing with a very high reliability. Over 0.95, that's too good to be true. Under 0.6, you're in some tricky territory, okay? So we want our reliability to be under 0.90 and above 0.60. Okay? That will be a quiz question for everyone. I don't know why I just sent it to Chengqian, Mr. Frank. I want to send it to everyone. Let me do that again. Okay? So we want a reliability under 0.9. I mean, they say to be higher, the better. But when you're over 0.9, that's really just too good to be true. And when you're under 0.6, even under 0.7, you get some questionable, you get some questions. Okay? So what I'm going to do next to follow the same procedure is I'm going to personally just check all of them. So let's do it this way, actually, since we have this. I'm going to pull in experimental mindset time 3, and I'm going to take out experimental mindset time 2. Okay. I'm going to click OK. And wow, it's even better. It's from 0.86 to 0.88. And baba, that's fatai, right? We all want to fatai. And with this time 3, I seem to have fatai. And you can see if I take out any of the items, everything drops, meaning it's very stable. And that's what I want to see, right? I don't want to see something where if I take out time 2, it drops to 0.4. That's really strange, right? I want to see nice, stability throughout all of the items, because these 6 items represent the concept experimental mindset. It's not one item that represents experimental mindset, it's all 6, okay? So let's do the same thing with experimental mindset time 4. Let's bring them over and let's take out this one. And let's just have another quick look of time 4. And it dropped a little, 0.87. And there is some reason for why this happened. Time 4 was when our Nian 12月15号, right? When the 政策 for COVID, for 疫情 ended, right? So it seemed like maybe there might have been some drop, very slight difference, but didn't affect the sample very much. So very stable for time 4. Let's take a look at time 5. So if you see how I do this, I am typing EXP. Here's time 5, boop, 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 bring them over, and let's take out time 4 and get them out of here. And then I do a quick check and it's back up to Baba. Very good for my Fatsai. I seem to be doing well. And again, we can see very nice stability for all of the items, meaning again that I don't want to take one out. Okay. If any of you have questions, you can go ahead and ask them. I'm sure that you might be having some questions that I'm not answering at this point. Please type them in the chat box. Here's time 6. And again, went up to 0.9. Okay. And we have found good reliability across all the items, across all the scales. What we're going to do next is go ahead and calculate them, right? Very simple. Because we're dealing with means, we're now at the point where we can go ahead and make our variables. Not all 7 or 6 items will be in the model. It's going to be one item, and that's the average of experimental mindset. Okay, so we could just type exp mind set T1. And what we're going to do is take all of these items from time 1 or from time 2, and we're going to bring them over. How do I do that? I just make a simple equation like this. I prefer to do this the old way. I know many of you are going to say, oh, teacher, that's very old school and it's very slow to do it this way. I like to look at it very clearly. You can make a function that says mean and then you put it in. That's also fine. I think what I'll do right now is show you the value of let's see what interesting. Ha 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 ha. This is why string data is so important, because it found that my file. So again, if I show you, it may not be here. Let's see. Okay. So if the reason what happened is it said that that file was not, that file was not in numeric, it was in string data. When it's string data, you cannot calculate. Huh, interesting. These are all numeric and they're all nominal. We can do it this way. You might have to change these to interval to make sure it's all going to be okay, right? So those are all now scale items and they're numeric, and that means their number. So let's see if this is going to solve, if it's going to solve that problem. So exp mindset time 2. And let's go to experimental mindset, take it over. take this over, 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 divide by 6, put this here. Again, I make a mean variable. Invalid combination of data types in the assignment character strings may only be assigned to strings. Numeric and use the string command to declare new function before assigning values to string or number function. Interesting. I've never seen that before. Interesting. Hmm. Let's see if I can. Okay. Huh. Okay. I encountered something I have not seen in a very long time because usually I have everything sort of ready to go. Let's see if we go here. But it's not a string, it's numeric. So those are all numeric. Okay, I found the problem. Okay, so you can see what happens. So I'm going to go ahead and finish calculating that. Um, did anyone catch what happened? So we need to make sure. Oh no, Yangjian, no, it's not. It's fun. We love research, right? It's so much fun. These are the challenges, but it's you got me, right? So here, when you go in here, when you're calculating your variables, you need to make sure, again, this is again why it's so important that your file, like here, they are not only scale, but they're also numeric. So these are my my 6 items that I'm calculating. As long as they're numeric and scale, then we're good, right? When you transfer over the file, sometimes it might just say it's nominal, and then you have to go in and manually change them one by one. I believe you might, I don't know if that actually has the feature where you can change them all at once. Um, if you do need to do something like that, I'm sure there's a formula that we could run in the syntax, and I'll happily work with you on that later if you have this problem. But that's what happened. Okay, that's what happened. Was these items needed to be calculated like that, right? I needed them to switch to scale. Right? It's my experimental mindset. I'm going to click OK. I'm going to change the variable name. And then now my output pulled up and it computed this variable, exp mindset time 2, and it's calculated it using that formula, right? I will show you the syntax later, the daima later, because that will save you a lot of trouble when you're doing this. But let me just do one more. So I already know that experimental mindset time 3 is going to be the same problem. So I'm going to go back over here to my file. I'm going to go down to experimental mindset time 3. And here we are. Right here. Okay. Again, you can see the problem. It's a numeric variable, but here it's listed as I'm changing them all to scale. And you can see that all of them have been changed to scale. This is time 3. I'm going to go back over and you can see, yeah, I need to probably reformat this, and I change this to time 3. I'm going to just take this away because this is all different from the previous one. I will type in exp, and then boom, boom, boom. Here, I put a parenthesis. You can also use this function here if you want, like this. Put in the parenthesis there, put a plus, put the parentheses there. You can also click plus if you want, put the parentheses there, click plus, put this plus, put this plus, put this, and then I take it out of the parentheses and I do divide it by 6. Okay? Experimental mindset time 3. Let me add in the T. A. Uh-oh. Oh, hi. That's very interesting. Oh, hi, Yuki. Welcome. Sheen. Bye, Yuki. I let's see if it will work. Oh, wow, that's fascinating. It took time too. I have to do it all again. Interesting. That's so interesting. Boom, plus, boom, plus, boom, plus, boom, plus, boom, plus, boom, divided by 6. And then this is going to be time 3. A character strings. Hmm. Hmm. Very interesting questions that are happening with this file. This one definitely worked. EXP. Oh, so what I just did, everyone, was I went down to the bottom of the data set. So once you actually run the compute function, it's going to put it at the very bottom of your data set. So I'm going to go ahead and put experimental mindset 3 here. And we're going to call it a scale variable. This is also going to be a scale variable. And then this way, when I do need it, you can see when it's calculated, it will show the mean scores, right? It will show the mean scores there, okay? I am not really sure why I'm not getting this one working for experimental mindset time 3. Can I have some questions typed into the chat box, please? What questions can I answer? You can type them, or if you prefer to speak them, why don't people go ahead and start typing in questions for me while I figure out this small little issue with my time 3. Oh, there it is. Look at that. It's still showing it as that. It's showing it as an actual nominal variable. Let's see if I just do this. Oh, it worked. Fascinating. Okay, so it's gonna work. Any questions?大家没有问题啊？我觉得这个是不可能的。Thank you, whoever this 勇敢的同学 is. Yeah, you actually, the requirement, that's a very good question, Stephen. So what's the requirement for using reliability? Um, the reliability needs at least 2 items to sometimes 3 items, right? You cannot do it with, more than, you cannot do it with 1 item, okay? So that's one important thing. So if you've only asked 1 item for something like how happy you are, you can't do a reliability, okay? Next question by Dolly. Whether should we examine outliers by z-score? Again, Dolly, as I said, outliers I recognize are very, very crucial factors to consider. However, I I will quickly look at outliers with skewness and kurtosis and see how the data looks. And sometimes I will use box plots to see where certain items are falling. But I don't ever deal with outliers at the start. I will do it if there's a problem with my data or my analyses later. Then I will go back and say, oh, that's my problem. That was my problem with an outlier. Maybe I need to go and check that. Right. So again, I, and this is just a personal strategy that I have is I don't personally go too detailed with it at the start. I will go sort of all the way through my steps of my data, and then I will see, oh, there was this problem. Okay, let me go back and check the outlier. Okay. Um, Hopefully that will help you. It really depends on what what your data looks like, because it could, if I see it right away, then I'm definitely going to deal with it. But if I'm not seeing anything, having any signs of outliers, as you saw with this variable, then I'm just not going to worry about it right away. And I'm just going to sort of see how the analyses look and deal with it later if it comes up. Okay. Thank you for the 2 questions from from the dear master students. Can I ask an undergrad to ask a question too? Wow, that's nice. So nice to see questions. And this is again from a master's student. If the reliability is over 0.9, Hello, sorry about that. This internet is not very reliable. Um, Eileen, I would say that we would need to carefully look at the data and see, what are some of the characteristics of the data? What should be your next step? I would look at your data. What are those features that are driving so many people to answer the question the exact same way? Point 9 to 9.95, it depends. What did the original scale do? Did the original scale also have such high reliability? Right? If so, then you have some justification for why yours is so high. If the original scale that you got your data, that you got this from, then that's a problem. Does that make sense? Okay, I'm going to finish calculating these because I want to show you one thing. So what I'm doing now is I'm calculating the other dimensions of experimental mindset, right? So I did time 4, I'm doing time 5 here. Make sure that you always have your pluses. Make sure you have your parentheses, right? All those things really matter when you're doing this little equation, right? You're making the equation. And the other great thing is you can look here to see to make sure you didn't have any mistakes, right? You should always be able to go back and change it and start over if you need to. That's always a very important thing as well. So I'm still waiting for a question from my undergrad students. Can I have a question from my undergrads who are here in the class? You can be in the capstone class. You can be in the 4230 class. You can be in someone else's class. 都可以。我就想有一个本科商业发言，或者是打字给我。太棒了。And who is the lucky dog? Wow, Mr. Kim, how are you, sir? Suppose the scale is divided into items into several categories. So this is a wonderful question, Mr. Kim, Mr. Jean. So I would definitely first check the sub dimensions of each. I would check the dimensions of each of them first. And then I would combine them into one big scale called, like yours is, career adaptability, right? So I would call it like the career adaptability. Let's say there are 4 dimensions. One is about exploring, and the other is about dedication. The other is about passion. These are work-related things. Let's say the 4th is about confidence. I would check each of the 4 separately and make sure those reliabilities are okay. Okay. Very good question. Thank you for representing the undergrads, Mr. Kim. Very good question. So here is the time 6, right? And then quickly we can go to time 7. I can go here to time 7, which is right here. 1, 2, 3, 4, 5, 6, divided by 6, put in the other parentheses, and then we click boom. Okay. All right. And then again, what's so cool, what I think is so awesome, and why I love research so much, is it's so stimulating, right? There's so many cool things you can do once you get things going. So all the way down at the bottom, we have made the time 2. We've made time 3. Okay, so I can't add those there. That's fine. So we have all of these that we have now created. I would recommend that you open them and you can see, wow, look, all the scores tend to be pretty closely related, right? And of course, what I'm going to expect in my hypothesis is that over time, well, I don't know if time 2 is going to predict time 7, but I would imagine over time, they're just going to keep going up, or at least they're going to stabilize, right? Or if you look here, this person, they went from a 1.3 to a 1 to a 1 to a 1 to a 1.5, and then suddenly to a 4. Maybe this person got a job here, right? Maybe they found something very special going on in their passion regarding their work. This person has been very stable all the way across. You can just see so many interesting features about just doing something like this, of calculating it. You can also see some people didn't complete it all, and that's very normal. I mean, right, we're dealing with busy people and a lot of overtime, right? So then what I could just do, just to sort of get a sense of the data, is just run a very small correlation. I would run bivariate correlation. And again, all I'm going to do, nothing complicated for tonight, is I'm just going to do a simple correlation with these 5 or 6 different times. Okay, I'm going to put them over here. I'm going to do two-tailed. Because I'm dealing with interval data, I'm going to do Pearson. If I'm using nominal data, I would click Spearman, right? And I'm just going to click OK and have a quick little look on what's going on with the data. And I don't think there we go. Okay. And again, as we expect, nothing super like innovative or anything. We could just see time 2 correlates with time 3 at 0.16. Time 2. So here, basic information, right? Here is the correlation R. Here is the significance down below. This is the p-value. And here is the n. This is the number of people, right? This means that from time 2, there's 405, 357, 315, 284, 297. I mean, these aren't going to change so much, but this is just what it looks like, right? So from time 2 to time 3, you can see that the correlation is 0.16. From time 2 to time 4, it's 0.599. Time 2 to time 5 is 0.6, so it got a little stronger. Actually, this is interesting because it's the strongest, right, of all the time. And then from time 2 to time 6, it's 0.508, and then it goes back up to 0.1512, right? So very, very interesting, just to give you a sense. As we would expect, these are correlated in a positive direction over time, right? Nothing innovative at this point. This is not like a my major finding, but I just wanted to show you correlation, because correlation is very useful, right? We're looking for understanding associations or correlations in the data, right? I could add age to here. I could add work satisfaction to here. I could add other things to see the correlations. I'm not going to do that tonight. I just want to show you why correlation can be useful. Okay. I want to go back and I want to find an item that I need to reverse score. So I need to look at my code book because I actually don't know what item I have here that needs to be reverse coded. I hope there's one. And then I can show you what it will look like when we do the reverse code. So what I'm looking for is an item that is R, like reverse code. Let's see if there's anything with an R. I think I would have done it like this. There we go. Look at that. This is talking about their expectations. They just started working. Please review your experience from the time you started working to present as a new employee. From your true feelings, how much do you agree with the following statements? My expectations for my job are low. I have the opportunity to stand out on my work. I have done an excellent job. And then number 4, my work is not helpful for me to improve myself. So this one is reverse and this one is reverse. Wonderful. We can now look at what will happen when we have reverse coded questions. So now we call this actual expectations 1 and 4. I'm going to go back to my data. I'm going to go and find that item, actual expectations. Maybe we just call it expectation, initial expectations, and then we call it later, we call it actual expectations. So here's question 1, here's question 2, here's question 3, here's question 4. Perfect. So I'm going to just first start by looking again at my simple, my frequencies of the data, just to get a sense of what is really going on with this data. Okay, so it's these ones here. I'm going to bring them over. I'm going to check the mean, the maximum, the range, and then the skewness and the kurtosis. I'm going to click OK. And here it's not as complicated, but you can get a sense. The minimum is 1, the max is 5, and boom, you can see all items are within the range. You can see there's going to be 405 people. The skewness is all okay in the recognized range. So you can even see here, look at how fascinating this is. From here, you can already gauge number 1 is positive and number 4 are positive, right? Those are the 2 ones where they're supposed to be reverse coded. 1 equals 5, 2 equals 4, 3 equals 3, 4 equals 2, and 5 equals 1. I'll show you what that means in a second. But here, you can see for item 1, most people are scoring, you can see, 1 and 2, right? Within 3, around 75% of the data. And that's the complete opposite for number 2. 89% are scoring around 4. Again, 88% are scoring around 4. And then again, if you look here, 69 to 84 are scoring at 3. That's obviously telling me some special thing about these reverse coded items. And I hope it's very clear for you to get a sense. We need to shift them, right? I can show you what it will look like if we don't. Okay, let's take these out and let's do a quick run on our reliability. Let's go to actual expectations time 2. Let's bring them over and let's bring over this and see what the, whoa, that's bad. Look at that correlate, the reliability. It's a negative 0.367. That's a very big problem. And if we take out item 3, we get a negative 0.9 correlation. That's a problem. If we take out item 4 and item 1, we would get an a correlation like that. Let's go ahead and first try to transform the variable. And how I do it is I recode to a different variable. There's 2 ways. You go to transform, you can click here, recode into the same variable. And that means that it's going to replace all of the numbers. That's a little risky if we have a problem. I recommend recode into a different variable, and let's go ahead and change the name of that variable. So first we're going to go and find it. We know it's number 1, and we know, is it number 3 or number 4? Let's check. We know it's going to be number 4, okay? So we're going to call this actual expectations, and then we'll put reversed, right? And we'll put reversed 1, and then we'll put time 2, okay? We'll save that, we'll bring it over, and here we're going to do the same, but we're calling this question 4. And now what it's doing is it's taking the original name and it's creating a new variable here, and I've added in the word reversed. So this way in my mind for later, I know that it's reverse coded. Okay. Then you go down here to old and new values because we need to change the value. We know 1 should become 5. We need to add it. 2 should become 4. We need to add it. 3 stays the same. We can save it. And 4 becomes 2. 大家睡觉了吗? 5 becomes 1. Perfect. We click continue and we can click OK. And now we know that those have been added to our data file. So let's go ahead and have a quick look. They're here. If we go all the way down to the bottom, and there they are. Those items have now been properly scored the right way. Then we can go back here to our reliability. We can take out number 4 and take out number 1. We can go all the way down here to the bottom and bring these two over. And fingers crossed the reliability can meet our needs. Boom, 0.752. Boy, are we lucky. And here you can see, if we take out item 2, if we take out these items, right, that they don't improve very much, right? If we take out item 2, it goes up just a little bit. It's not substantial to make a justification to remove the item. In fact, I highly disregard anyone doing that. Hold on 1 second, everyone. 喂，哎，你好。好了好了，那你麻烦你早一点就好了，可以吗？好的，谢谢啊，好，拜拜，好啊，谢谢，拜拜。Okay, sorry everyone, dealing with Kuaidi as you know, our life. So this is a great example of where we were able to use reverse coded and succeeded. There might be times where your reverse code do not. It is a very tricky practice because reverse coding plays into the idea that everyone's taking their sweet time answering the questions when we know our friends or we know people that are taking the surveys and they're not, right? So please just be mindful. If you have reverse coded, you need to practice this and see what happens. So then what I'll do next, let's just say, is I'm going to quickly just compute this variable, and I call it expectations time 2. and I'm just going to take those two items down here, right? We need those two to be in our model. And then I need to go all the way back up here to find the other two actual expectations, right? So we have question 2, we have question 3, and we have question 5. And then we can divide it by 5, and we can go ahead and save this variable as actual expectations question 5. Okay? And now we've computed our other variable, right? And let's say we had some theory to say that expectations will lead to more experimental mindset later, meaning that I feel very comfortable in my workplace. I feel like there's a lot of things I can do and it's met my expectations. 就是我的工作期待就是满足了。我后面是可以更多探索我的工作, right? I can be more experimental. So maybe we might have that prediction that experimental mindset is going to be an outcome of this, right? So let's say we bring those out and we bring them in, and now we're just going to look at actual expectations and what's the likelihood of it predicting later experimental mindset. And actually it does. Fascinating. We're not interested in the relationship with it at time 2 because we can see it over time 3, but we can see that actually how people feel in their job at the beginning of their company when they work still predicts their experimental mindset around 14 or 15 months later, right? Although it is weaker from 0.336 to 0.210, it still remains significant, which is, again, not something I would hypothesize, but just really kind of interesting to look at in the data, right? It showed us some very interesting things. Okay, I would like to take a few more questions. So I've taken 3 questions from MA students, and I've taken 1 question from 4940. I would like something from 4230. I would like a question or 2 from 4230. If anyone else has a question from 4940, please go ahead and just type it in the chat box. Or 如果你就要说，你就可以说啊，没关系，打开你的麦克风吧，我们都是朋友。Bruce, Marie, 黄丽, Bertie, Melody, do you have a question? Isar, do you have a question? Jai, Simon, nice to see you online. Do you have a question? Maybe you might have some questions. Yuki, do you have a question? Or Grace? All right, so this means that these questions, what I just taught tonight, can be these questions can be on the quiz later. Everything I taught tonight, I can put on a quiz and everyone will get 100 score, right? 100%, right? For a quiz. Bertie, you're confused about the expectation. So I don't think it's not very meaningful, this sort of question. It's a very 你的问题应该是算是理论的问题，不是统计的问题。我先就从理论的角度就跟你说一下，就是你的工作期待，对吧？就是你在工作当中你的期待是怎么样？I have the opportunity to stand out at my job. I have done an excellent job. I'm satisfied with my job, right? These questions. And then if we go down to look at these things about experimental mindset, are showing that there's some correlation. 就是他们如果在那边 expectation 是很高的，可能他在这个 experimental mindset 也很高的，它是相关的。And this 相关的 carries on over time. However, it's not a very strong effect. And it's maybe not so like it's like not 肯定的，我们都知道啊, it's not something that's novel. 不是很创新的一个点, right? It's just something I wanted to show you on how you could begin exploring your data more than maybe you have done so in the past, right? Thank you. Thank you very much, Bertie. So any questions from anyone else? Or should we go ahead and call it an evening and I can let this recording be saved online for everyone to view before the final? Eric or Roy? Okay, those three people that asked me questions, I will go ahead and give you the one extra point for your 主动. Okay, so Yuhua and Dolly and Steven and Kim, make sure next time we meet, you tell me and you'll get the extra credit for participating in tonight's lecture and asking a question, okay?
Hello,
Everyone.
hello, Professor. I have a question about how to choose the items to find the correlations, because maybe in different questionnaires, the question maybe seems like they have a correlation, but the result is not show the good correlationship. So that's going to be a question for me.
Okay, yeah, very good. Thank you, Wang Chui. Kathy, thank you. I can tell your voice, it's you. Very nice to hear your voice tonight. So remember, when you say when you say items, I don't think we should really be doing any correlation with single items unless you're doing an experiment or you have a real reason to have one question to represent one concept. 我的意思是，这 emerging adult identity 它不是一个问题，我们问它，我们用8个问题来明确这个问题是在描述这个 emerging adulthood identity。所以我先要强调一个，就是不是一个唯一的 question，它是一起的 career identity。我的事业身份认同，它是5个。So 肯定要先 right? First, you need to check the reliability. You also need to check the skewness and make sure the data doesn't have any common problems with the numbers. And then you compute it with the reliability is good. Then you compute it and you make a variable, right? 它的变量就叫 career identity. 那我想看 career identity, 它这个变量和一个变量叫 turnover intention. 它有没有关系？Turnover and tension 的概念就是我要辞职，我要离开这个公司，那它是两个问题啊。当然，我们要明确这个两个问题能不能放在一起 ，reliability 怎么样，能不能代表这个 turnover and tension？那如果是可以的，如果是可靠的，那我们可以看 turnover and tension 这个变量和 career identity 这个变量它的相关关系是怎么样？我会预测是负相关。The more career identity I have, the less I want to leave the job. That's also a very common expectation. So Wang Chui, if your items or your questions are showing some very strange result, or they're not showing some correlation, we need to see, is it because the data is a problem? Is it because the reliability has some problem? Is it because your sample is too small? Right? There could be 很多很多可能性的, right? It also could just be that maybe these two variables really do not make sense to correlate, right? Wang Chui, can you tell me the variables that you're want to correlate? Kathy?
Okay, I just saw the um maybe just like in the back, I'm satisfied with the nature of the work you're working, and maybe I think they will really there will maybe some have some correlation with the maybe with many of questions in the job satisfaction. So maybe one of this question is related to the nature of the work, and so
But here you're taking a single question, right? For our
okay.
studies for correlation, we have the items, but the items represent a variable, right?
Yeah.
Subjective well-being, 生活满意度，虽然它是5个单独的一个问题，我们都要看它的整个5个问题的平均。
Okay, so maybe the variable that I want to test is about the job satisfaction and the emerging adulthood thriving. Yes, maybe these two variable it's have relationship, but sometimes if we test in the SPSS, they maybe in the results they maybe couldn't show the really great correlationship. So yes, so
Okay,
we need
so
to try many times about other variables, or we just need to find another way to test the correlationship.
well, I mean, we have 10 questions, 10 items that represent emerging adulthood thriving. You can see there's 2 that are reverse coded. Did we reverse code them correctly, right? Everything 这个统计方法是有顺序啊，大家非常要讲究这个顺序，不能一下子就计算就说哦，我好了，我没有看 correlation，我没有看 reliability，我也没有把 reverse coded 就好了，我就随便计算就做这个分析方法就好了。You have to first check, are there any problems with the questions? Did you reverse code them? Did you make sure that all of the questions are 1 to 5? Is there some random number that's 100 in there? You never know. You're dealing with data. You're moving data from Windmachine or Qualtrics to Excel, from Excel to SPSS. It's very easy that the data could have some small error, right? And then after we see that we have reverse coded these to the correct direction, and let's say we do get a very good reliability here of 0.88, right? Then we say, okay, emerging adulthood thriving is ready. Now let me go check job satisfaction. And then we check all these items. There's 6 items. They're also running and working well. Everything's perfect. And their reliability is 0.85, right? And then I calculate them and I try to correlate them and I find that they're not correlated. I would be very shocked if you had a reliability of 0.88 and a reliability of 0.85, and these two are not correlated. I would be very shocked. Now, if your reliability is 0.6 and your reliability is 0.8, I won't be so shocked, right? If if you do have some small correlation, then I would start to think, well, maybe you're asking students and students don't have jobs, right? Then I would start getting down to the fundamental factor about what's your sample? Oh, I'm doing a sample of kids in middle school, 高中同学，那肯定他们没有 job satisfaction, right? Then you get down to those small questions that we begin thinking, 啊，我们这个数据或者我们这个样本有问题啊，right? So there are many things that might explain that before you can just say, oh, 不显著, right? And then again, like I said with Dolly very early, we can then also test outliers. If you get to a point where this has a very high correlation or very high reliability, and this has a very high reliability, and there's still no correlation, then I say, okay, let's go back and let's look at the outliers, right? Let's see what's going on with your data, because it's definitely a problem with the data. Because these two variables will correlate, and they'll correlate positively. Thriving means 很有成就感 and 工作满意度就非常满意啊, right? Of course, these are going to be related, right? Anyway, I think it's very good. Thank you, Kathy, for us, because some other people might have similar questions. And now I've given you some ideas of what you should do next, right? How do you deal with your data if you get to that point? And it's good if you get to that point. That means you've gotten all the way through the other steps. So I think we can stop here unless there's another question. Thank you for the question, Kathy. Very good one. And anyone else have a question? Okay. I wish you all
Hi, Alex.
happy. 哇，太好了。Hi,
This is Nano. Yeah.
hi, Nano. 好久不见。
Yes. I have a question. Maybe a little bit stupid, but
No,
I
no
want to
stupid
ask.
question. No
Yes.
stupid question.
I want to know how can I test the relationship between my demographic information and my independent variable.
Yeah, very good. So I didn't do that at all, but you could, so first what I would do is make sure, let's say we just want to do gender, right? Gender is always probably going to be near the beginning of your data, and you can just quickly look here. In this data set, I think gender is going to be 2, a female is 2, and male is 1, right? So let's just quickly make a note of that. We'll put this here. I will put 1, and this is male, and then this is 2, this is female, right? I know this because I know my data. So there's this one. Let's say we're also interested in, let's see, an easy one that will be here. Mom education, right? So this is, here we ask the question about their parents' education, and the higher the education, let's check. Let's see what the codebook says. code book for this one is going to be here. And it's going to be education. Maybe it's in time one. Here we go. Here, the highest degree your mother or father earned. Okay. And these are going to be higher, like 7 is a PhD and 1 is maybe like 初中或高中毕业, right? So we can just leave those two there, mom and dad education, and we can look at gender as well. So all we can do, I'm not a big fan of looking at this in this way, but you can do a small little test of it, right? I would say 回归分析 is better. Once you've made your model, you do a regression, but I can just show you this to show you what it looks like. So there's gender, and then let's pull over mom and dad education. And again, you click on Spearman correlation down here. This you're going to use for these 3 variables with these ones, because these are all categorical variables, right? They're the numbers don't have a number. They're just like 1 is male and 2 is female. 7 is PhD, 6 is master, right? The meaning is not the same as like a 5 for experimental mindset means you're very high in experimental mindset. The difference is different, right? And then you just click OK. Move you over. And then you'll be able to see, right, the correlation here. So gender and mom and dad education have some small relationship. So you can see with the stars, that means that they're significant. It's not very strong. It's at 0.14 and 0.142. I mean, this one, the mother's education carries on to time 4 experimental mindset. So I think that's kind of interesting, is that after the kid has gone to work, if the mom is very highly educated, the child continues to be more experimentally engaging in work at time 4, right? And that's interesting, because that means like the mom has some effect on them over time, like as they're getting used to the life. It's stronger with mom than dad, right? Because here you can see father at time 4 is not, it's close, but it's not there. So that could be meaningful. I mean, that could just be meaningful to show like that mom has some effect early on in their child's work, but over time it goes away. It becomes more the child is doing their own experimental mindset based on themselves, and their mom's and their parents' education has less and less of an effect, which makes perfect sense. And that's kind of interesting. Gender, if you see, doesn't seem to tell us much at all, right? It doesn't seem to show anything in terms of, I mean, it does for this time 2, but because we have this long data, I would just say it doesn't really have an effect at all, right? Because after that, it's gone, it disappears. So I would look at it that way, Nano, but later when you start doing more with it and you make your regression model, then you could make it more clear as to the variables that are categorical, like gender or education or maybe hometown. Maybe you have a variable like city versus rural. Maybe someone grew up 在农村长大 versus someone that's like 在城市长大, right? That would be a very interesting one for because you're looking at pets. Maybe people that are in the city, the people living in cities might have more pets, right? I think is for your project.
Yes. Okay, thank you.
Great. Okay, everyone, I can keep talking all night, but I think we all want to go and enjoy the May holiday. So I wish you all a wonderful holiday. Remember, you all have a deadline coming soon, or most of you have a 30th deadline coming. But then after that, please have fun. Remember, work hard, play hard, right? So please make sure that you continue doing your work during the May holiday, when you're on the train, when you're in a coffee shop for an hour. Do your work and then go out and see the city and go play and have fun, okay? Wish you all a good time and see you next month in May, okay? Have a good night.
Okay, bye.
Bye.